Alright, this video we're going to take a look at complex numbers. So before we get started, let's take a look at a couple of definitions first. So our first definition we're going to look at is imaginary numbers. The imaginary number I. So it's defined by I squared is equal to -1, and we can also write that I is equal to the square root of -1. Okay, so this is going to be important. Both of them are. That and this, we'll use that later on in the video. And then we have a complex number. The set of complex numbers is the set of all numbers of the form a plus bi, where a and b are real numbers. Okay, and in this complex number here, a plus bi, which I have written right here, a is called the real part and b is called the imaginary part. All right, now let's look at this first example, and let me say one thing before we do. This form here, this is important, this form. This is how you're going to write your answers. You're going to write your answers in this form. It's important that you do that, okay? And the reason I say that is because in other math courses, it's important to have it in this form, because you'll work with complex numbers in other classes, and a lot of times in those classes we need to be able to identify what A is, and we need to be able to identify what B is. So, you know, whenever you're writing these things, write them in this form here. And this is the standard form of a complex number. Okay, but now let me say this before we start on this next example, or this first example. There's variations of the way that we write these things, and it's kind of for convenience. Okay, so in some of these, A could be 0, B could be 0. Okay, so if you look at some imaginary numbers, let's just go up here. For instance, if we have 0 plus 3i, okay, well, that is equal to the same thing. That's equal to 3i. Or if we have 2 plus 0 times I, well, 0 times I is 0, and 2 plus 0 is 2, okay? And then also, if we have this, okay, we have B as a radical. Well, this is how we write it. We don't write it, I mean, it's the same thing as 2 plus square root of 3i. It's the same thing. But we don't write it like this because you could accidentally write it. You know, you could write something like that, and in that problem, it kind of looks like the I is underneath the radical when you're not intending it to be. So for that reason, we write the I in front of the radical, and now there's no mistake about the there's no mistake that the I is not under the radical. We know it's not under the radical. Okay, and then another thing you might see written like this. Okay, 3 plus -2i, where B in this case is -2. Okay, now this would be the same thing as this, and this is how we would write it. We wouldn't write it like this. It's not wrong to do that, but we just write it like this. That avoids the plus and the the minus in the parentheses, the -2. Okay, so that's a few little things there. All right, let's look at example 1. So it says, determine whether each complex number is real or imaginary and write it in standard form. All right, so let's just write the standard form for a complex number down. It's that a plus bi. And they're wanting us to determine whether it's imaginary or real, and then write it in standard form. Okay? So this a plus bi, the thing you've got to understand here, how do we know if it's real or imaginary? Well, if b is 0, okay, if let's just say b is 0, then 0 times I is 0, right? And a plus 0 is just a. Okay, so if b is 0, then that means the complex number is real. If b is not equal to 0, then you can see how the imaginary part would still be there. It doesn't matter if a is 0 or not. We're just talking about the b. But if b is not equal to 0, then the complex number is imaginary. Okay? So let's determine if it's real or imaginary, and then let's write it in standard form. Okay? Now, so we've got 3i. Okay? So is this real or imaginary? Well, there's b. b is 3. So this would be imaginary. And then if we write it in standard form, that would be what? 0 plus 3i. See, in this problem, a is 0. Okay? Now, what I want you to understand as I'm writing these things down in standard form, this part over here, as I go down through the problems, this is not how you're going to write it. Okay? You would leave it like this. Okay? If you have 3i, you're not going to write that as 0 plus 3i. Okay? We're just doing this because it's asking us to write it in standard form. That's the only reason we're doing the 0 plus 3i. All right, let's look at the next one. 87. So is that real or imaginary? Well, there's no b term, is it? There's no b times I. This is real. And to write it in standard form, that would be 87 plus 0 times I. And so this would be 87 written in standard form. Okay? And like I said, this is not how you would write it. You would write it like this over here. Remember how we talked up here about how we write these things for convenience. Okay? But I'm just going over this because your book may have some problems for you to do this. All right, let's look at this one. 4 minus 5i. Well, we can see this would be imaginary. Okay. And to write it in standard form, we would write what? 4. Remember, let me write that down again. All right. And notice when you have this, there's a plus sign there. So it would be plus negative 5i. So that's your complex number written in standard form. Okay? So, but once again, this is not how you would leave it. For convenience, we would write it like this. And this is how you would write it if you were working any other problem, if it wasn't asking you to write it in standard form. Now, what about this one, 0? Well, in this case, b is 0, right? So this would be real. And so we would write 0 plus 0i. Right? What about this one? This one is imaginary. All right? And so now to write this in standard form, we would split it up. So that would be 1/2 plus pi over 2 times I. All right. Now, let me say this. Now, I mentioned the whole time that we were working these that this is not how you would actually, that this is not actually how you would write the answers, what I have circled here. You would write them like we have them over here. But now this one, as far as me, if you're in my class, I want you to write it like this instead of like this. If you have a fraction like this, I want you to split it up. And I don't know, most of your teachers, they may want you to split it up like this. I don't know, but I would want you to. So we can easily identify A and B. Okay, that's the reason. All right, so let's look at this example. Perform the indicated operation. So we're going to be adding, subtracting, and multiplying in this one, and then later on we'll be dividing them. Okay, all right, so perform the indicated operation. So we've got -2 plus 3i plus -4 minus 9i. Now, whenever you're adding or subtracting these complex numbers, you want to add the real parts together and add the imaginary parts together. So you can see here we've got the real parts, and here we have the imaginary parts. So I've got -2 plus -4 is -6, and 3i plus -9i is -6i. And there's your answer. All right. Let's look at the next one. I've got -1 minus 5i minus 3 minus 2i. All right. So let's subtract them. Now, the first thing I'm going to do here is I'm going to write this as -1 minus 5i, and I'm going to change the minus to a plus. Okay? And let me just go through of what we're doing here, and then I'll explain why I'm doing it. So I'm changing the minus to a plus. And remember, whenever you change a minus to a plus, you have to change the sign of each one of these terms. So that would be -3 plus 2i. And now I can work it like I did problem A. All right, now why did I do that? So the reason I did that is because it's easier to add than it is to subtract. Do you have to do this step right here? Do you have to change it to a plus? Absolutely not. You don't have to change it to a plus sign. Okay, you don't have to. But I've found that a lot of students, whenever they're subtracting these things, if they try to do the -1 minus 3 and the -5i minus -2i, they tend to make careless mistakes when they're trying to subtract them like that. And then I found that if you will just change it to an addition problem, so you change this to a plus, that's all we're doing, changing that to a plus, and then you've got to change the sign of each one of those. And then you add them. I've found that students tend to not make the careless mistakes when they're adding instead of subtracting. And that's why I'm changing this to a addition problem. So I've got -1 plus -3 is -4. -5i plus -2i is minus 3i. And there's your answer. All right, now we're going to multiply them. All right, let's multiply them. So here, well, we're just going to distribute, right? So that's going to be what? 6i plus 2i squared. Now, remember, whenever you're adding these things, multiplying them, dividing, subtracting, whatever you're doing, we want to write it in the form a plus bi. That's the form we want it in. Okay? So now we have what? 6i plus 2 times negative 1. Now, where did the negative 1 come from? Well, remember, up here, I squared is equal to negative 1. So all I did is I changed the I squared to negative 1. And so this gives me 6i minus 2. And so this is equal to negative 2 plus 6i. See, I'm writing it in the form a plus bi. All right. All right, let's look at the next problem. Now here I have two binomials that I'm multiplying together. So how am I going to multiply these together? Well, you've probably guessed it. We're going to use the full method. So this, I'll multiply the first. So that's 2. 2 times 1 is 2. The outside, 2 times negative 2i is minus 4i. The inside, 3i times 1 is 3i. And then the last, 3i times negative 2i is minus 6i squared. All right, so now I've got to simplify this thing. So that's going to be 2. And here I'm going to combine like terms. So that's 2 minus I plus 6. All right. So if you're taking notes, just write that down. How did I get the 6? Well, do you see how I went from I squared to negative 1, and then a negative 1 times a positive 2 was a minus 2. That's all I did. See how this was plus, and now there it's minus, okay? And the I squared's gone. All I did is I did this part right here in my head. Now, if you need to write this step in, go ahead and write the step in every time, okay? But what this is doing is it's saving you a step. So remember, I squared is negative 1, right? So negative 1 times negative 6 is positive 6. That's where that positive 6 comes from. And then I just combine like terms. So 2 plus 6 is 8 minus I. And there's your answer. All right. Now let's look at this one. This is two binomials multiplied together. I've got full method, right? Okay. So we get up there and we say, okay, well, we can do the full method. But with this problem, I noticed something. Okay. I noticed something. This right here kind of looks like a minus b times a plus b is a squared minus b squared. Okay, so you probably recognize that. All right, and if you've watched the previous videos for these college algebra lectures, then you've definitely seen that. All right, so that's what it looks like. Okay, but it's a little bit different. It's this instead. Right? That's what it is instead. A minus bi times a plus bi. Well, guess what? This has a formula also. Okay? And it is a squared plus b squared. All right? So that makes it a lot easier. We don't need to full it out. We can just use the formula here. Now, in this problem, a is what? A is 5. So that's going to be 5 squared plus, and then what's b? Well, remember, b is the number in front of I. So b is 2 plus 2 squared. So that's 25 plus 4, which equals 29. All right. Now, if you don't understand this, okay, I've had students in the past that this right here confuses them. They get lost doing it, okay? Or they don't feel comfortable doing it, at first. Well, look, if what I did here, if that confuses you plugging it into this, then fold it out like we did that one. You'll get the same answer. Okay? It'll add a few more steps, but you'll get the same answer. Okay? So like I said, throughout the video, I'm going to use this. But like I said, if this confuses you, just fold it out and you'll get the same answer. All right, now here we want to simplify. So we've got I raised to the 44. Now, this I to the 44, what does that equal? Well, let's write down what we do know. We know that I squared is equal to -1, right? We know that. So I could write this I to the 44 as I squared raised to the 22nd, right? I could do that. All right. Because remember, when it's in this form, what do? You multiply the exponents. So 2 times 22, that gives me my I to the 44. And so then, well, what do we have? I squared is what? -1 raised to the 22nd, which that is +1. And actually what I want to do, and I hope that made sense, what I want to do here is change this to the 83rd power instead of 82nd. All right. All right, so let's look at this one. So what is I raised to the 83? Well, we don't know. Now, I know I squared, don't I? But how can I do I squared raised to something where 2 times that number is 83 without getting a decimal? Okay. Well, 2 doesn't go into 83 evenly. So the first thing I'm going to do is this I raised to the 83, I'm going to rewrite it as I times I to the 82. Okay, I just split it up. Now remember, this is I to the first power times I to the 82nd. That's equal to what? I to the 1 plus 82, which that gives me I to the 83, right? I just rewrote the problem. That's all I did. I wrote it different. All right. Remember, when you have like bases, you're multiplying, you add the exponents. So now I've got I times, and then this is what? I squared to the what? 41, right? Because 2 times 41 is the 82. So this is going to be I times -1 to the 41st. All right. And so that's going to give us I times and -1 raised to the 41st. Well, when you raise -1 to an odd power, that's going to give you -1 as an answer. And so -1 times I is just -I. All right. So I hope that helped. Now let's look at these. Write each quotient in the form a plus bi. Now, before we get started on these, the first thing I want to point out is we want it in the form a plus bi, and the problem we have is this I down here in the denominator. So what this might remind you of, if you're at this point in your college algebra class, then you've already gone over this. Rationalizing a denominator. Remember what you did? You multiplied numerator and denominator by the conjugate of the denominator, and that got rid of the radical in the denominator. Look at this. These are conjugates, right? Remember, the sign in between them is different. And what happened when we multiplied the conjugates? The I went away, didn't it? See how we just got 29? So that's all we're doing. It's going to be similar to when we were rationalizing denominators. Okay? So for this one, let's multiply numerator and denominator by the conjugate of the denominator. All right. So let's multiply the numerators together, multiply denominators together. So here I'm going to distribute the 1. So 1 times 5 is 5. 1 times 4i is 4i. So there's my numerator. Now here, when we multiply that, well, remember, that's just what? A squared plus b squared, like I did in that previous problem. So that's going to be a squared, a is 5, plus b squared, b is 4. And so that's going to be 5 plus 4i over 25 plus 16. Okay. So this is going to be 5 plus 4i over, and then let's see, 25 plus 16 is 41. Okay. Now, we want it in this form a plus bi. So what I want to do is I want to split this up. So that's going to be 5 over 41 plus 4 over 41i. And there's your answer. All right, let's look at another one. Let's look at this one. So I want to multiply numerator and denominator by the conjugate of the denominator. So I'm going to multiply by 2 minus I over 2 minus I. So in the numerator, we want to FOIL that, right? We want to FOIL it. So let's multiply the first. 8 times 2 is 16. The outside, 8 times negative I is minus 8i. Inside, negative I times 2 is negative 2i. And then negative I times negative I is positive I squared. And that's over a squared, which is 2 squared, plus b squared. Now don't mess up here. This is what I get all the time. And that's not the case. Remember, a minus bi times a plus bi is equal to a squared plus b squared. b squared. b is the number in front of I. What's in front of I? It's understood to be a 1 plus 1 squared. And so now we've got 16 minus 10i, the negative 8i minus 2i, minus 1. I squared is negative 1, right? Okay. Over 4 plus 1. And so this is going to give me 15 minus 10i over 5. And then I'm going to split it up. 15 over 5 minus 10 over 5i. And that gives me 3 minus 2i. And there's my answer. All right, so I hope all this is making sense for you. We just got a couple more. We got this one and then these. Okay? Just hang in there. All right, so this problem here, 3 minus 2i. I need to get that I out of the denominator. Now, there's actually, for this problem, there is actually two ways that I could do this one, okay? And which way do you work it? Well, I mean, really, it doesn't matter. What I'm going to do, I'm going to go ahead and do it both ways just to show you what happens. So first, real quick, I'm going to work it the way that I wouldn't normally work it, okay? Which is not the wrong way to work it. So basically what we're doing, we're just wanting to get the I out of the denominator, right? So if I multiply numerator and denominator by I, okay, I'm going to go through this quick, then that would give me what? 3i minus 2i squared over I squared, right? Distribute the I, and then I times I is I squared. And so that's going to be 3i, and then remember, I squared is -1, so -1 and -2 is +2, over, and I squared is -1. And so that's going to give me -3i minus 2, if I distribute the -1 into each of them. And so that would be -2 minus 3i. And that would be your answer. Okay? So just remember, we got -2 minus 3i as our answer. Now, I'm going to work it a little different than that. And by no means is this a big deal. Well, why couldn't we just work it like this? It's the same thing. You can. Okay? I'm just going to show you something here, and what it's going to do is it's going to avoid you having that negative in the denominator. Is it a big deal if we get that negative in the denominator? Remember, we had that -1 there in the denominator. It's not a big deal, okay? But let's look at it. So I multiplied numerator and denominator by I. I could also multiply numerator and denominator by -i. Okay? And if you think about it, if you look at the problems we did here and the ones we did here, we multiplied numerator and denominator by the conjugate of the denominator, right? Well, we know that I is the same thing as 0 plus I, right? And the conjugate of that would be 0 minus I. And if we do 0 minus I, that's just -i, and that's that -i right there. Okay? But like I said, multiplying numerator and denominator by -i, or multiplying numerator and denominator by +i, it's not that big of a deal. Okay? It's not that big of a deal. So let's work it. So let's distribute the -i. So that's -3i plus 2i squared. Okay, -i times 3 is -3i. -i times -2i is +2i squared over -i squared. I times -i, negative times positive is negative, and I times I, that's I squared. And so this is -3i. Now this is 2, +2 times -1 is -2 over. Now I squared is -1. -1 and the negative here, the negative and negative make it +1. And then all I do is I just rewrite it. I'll rewrite it with the -2 first. And you see, that's the only difference it made. I didn't have to distribute that -1 to each of those terms in the numerator. And like I said, it's not that big of a deal. But I just think it's, it's just a little bit easier. That's all. Okay? All right. Simplifying expressions. So let's look at this. We want to find the square root of -12. So when I went over the section on radicals and stuff, simplifying those radicals, you can't take the square root of a negative number. Well, let me not say that. The square root of a negative number is, the answer would be not a real number. Okay? It's not a real number. So I'm gonna work this out two ways. The first way that I work it out, I'm gonna work it out showing every step, all the details. Okay? And then I'm gonna come back and I'm gonna work it again. I'm gonna leave some of that out. Okay? But I want to work it one time so you can see all the details and what's going on. And then I think that'll make more sense of the things I leave out. Okay? All right, so let's get started. So I've got square root of negative 12. Well, this is the same thing as negative 1 times 12, right? Negative 1 times 12. And that is equal to the square root of negative 1 times the square root of 12. If you remember back when we did radicals, I can split those radicals up. And I know the square root of negative 1 is equal to I. That was that very first property that we looked at. Okay, remember it said, let me just go on back up here so I can show you. See, we may also write I is equal to the square root of negative 1, and that's where that came from. Okay, so let's come back down here. All right, so the square root of negative 1, that's I, times the square root. Now, this square root of 12, I need to simplify that, don't I? Okay, so 12 is 4 times 3, and so the square root of 4 is 2. So that's going to be 2 times I times square root of 3. And there's your answer. Okay. Now, how are we going to actually work it? Well, let me show you. All right. So the way that we're going to work this is, look at this, square root of negative 12. You see that negative? That's negative 1, right? What's the square root of negative 1? I. Just go ahead and bring it out. Okay? Don't do this and then split it up and then do it. Just write I square root of 12. Okay? So basically what I did is I'm leaving this out. All right? And then we just simplify square root of 12. So that's I square root of 4 times 3 equals square root of 4, that's 2I square root of 3. All right? And yes, look, if you wanted to, you could have just done this. I square root, and then you got to simplify 12. Could have went straight to that. That would have been even shorter. Okay? But the thing I'm getting at is leaving this out. Now, if you need to write this in because it helps you, then by all means write it. Okay? And I'm not saying you can't work it like that. You can if you need to, but this is a little bit easier. And it's really not that hard to understand. All right. So let's add the two. So remember, in order to add or subtract radicals, the index of the radical has to be the same, and what's underneath the radicals have to be the same. So this is going to give me I square root of 8 plus I square root of 18. Okay, just went ahead and got the negatives out from underneath the radicals, the negative 1, because the square root of negative 1 is I. Now, let's simplify each radical. So that's going to be I square root of 4 times 2 plus I square root of 9 times 2. All I'm doing right now is simplifying the square root of 8 and the square root of 18. This was in a previous lesson on radicals. All right. So for this, the square root of 4 is 2. So that's 2I square root of 2. That 2 stays underneath. Plus, and then square root of 9 is 3, so that's 3I, and then that 2 has to stay underneath. And now, Well, look. It's like I've got like terms now. I square root of 2, I square root of 2. 2 plus 3 is 5, so that's 5i square root of 2. And there's the answer. All right, now what about this one? Negative 4 plus square root of negative 50 over 4. All right, we want to write this in the form a plus bi. That's the form we want it in. So let's get started. So first thing I'm going to do, I'm going to simplify this radical. That's all I'm working on, is simplifying that radical. So that's negative 4 plus I square root of 50 over 4. All right. So that square root of negative 1 is I. Now let's simplify the square root of 50. So that's going to be negative 4 plus I square root of 25 times 2 over 4. And so that's going to be negative 4 plus square root of 25 is 5. 5i square root of 2 over 4. All right. Now let's split it up. Negative 4 over 4 plus 5i square root of 2 over 4. And so that would be negative 1 plus, and I mean, yeah, that's negative 1. Go ahead and do that. Now, as far as this part here goes, I really don't care if you leave it like this. That's fine. You may see it written like this: 5 square root of 2 over 4 times I. Okay, and the reason, I mean, you know, the reason it would be written like this is we can identify A and we can identify B easily. Okay. All right. So now let's look at this. We got two more, this one and this one. If you're still watching the video, don't stop now. Just go ahead and you can make it through the rest of it. Okay. All right, square root of negative 9 times square root of negative 16. Now, we can't just multiply the 9 and the 16 and then take the square root. We've got negatives under each one. Okay? You've got to simplify the radicals first before you multiply them together. Okay? Now, if this were the square root of 9 times the square root of 16, they're both of them positive, or the square root of negative 9 times the square root of 16, one negative, one positive, you could, let me see what 9 times 16 is. That's 144. That would be the square root of 144. This would be the square root of negative 144. Okay? And then, you know, you would get what? 12, and then this you would get 12i. All right? And that would be fine. Okay? But if both numbers are negative, you can't do it like this. All right? You can't do it. So you might be wondering, well, what if I forget? Can I multiply them, or do I have to simplify them first? Okay, if you come up to a problem and you're not sure if you can go ahead and multiply them together like I did over here, or do I need to simplify them first and then multiply them? If you're not sure, simplify them first and then multiply. You can't go wrong doing that. Okay. All right. So the square root of negative 9, well, we know that's negative 1, so that's I, right? And the square root of 9 is 3, so that's just 3i, times, and then the square root of negative 16, that would be 4i, and then we multiply them together, so that would be 12i squared. I squared is what? Negative 1. Negative 1 times 12 is negative 12. All right. All right, last one. So we've got radicals, and I need to distribute. But before I distribute, I need to do what? Let's simplify the radicals first. Okay, let's simplify the radicals first. So this is going to be I, right? Square root. And I tell you what, let's go ahead and get dangerous on this one. Okay, we're pretty good with this stuff now. Simplifying 27. Let's go ahead and write it as 9 times 3. Okay. Times square root of 9 is 3 minus I square root of 2. Okay. See the -1? That's I, right? So that's going to give us square root of 9 is 3. So that's 3I square root of 3. That 3 stays underneath. Times 3 minus I square root of 2. And now, look at that. I'm ready to distribute. So 3I square root of 3 times 3, that is 9I square root of 3. See, the 3 times this 3 is 9, right? And then minus, so now let's multiply these. So that's going to be what? 3I squared. See, the I times I is I squared, and square root of 3 times square root of 2, that is square root of 6. And so I get 9I square root of 3. Well, look at this. I squared is -1, -1, and a negative. That's positive. Right. And then, of course, we want to write it in the form a plus bi. And so that's going to be 3 square root of 6 plus 9I square root of 3. And there's your answer. All right. So I hope all that made sense. I hope you feel smarter now. Check out my other videos. Give me a like, share, and subscribe. And thanks for watching.